All right, guys. Welcome to this week's Zoom. So we're going to be covering basically the progress that we've made thus far, going over some of the roadmap items. We have officially begun Tritium++ development after the last hard fork. So consider the very last version 3.0 as the last Tritium build. So all the hard forks from here are going to be basically Tritium++, or labeled as Tritium++. So Tritium++, for those of you that aren't familiar with what it is going to be deployed as, it's going to be deployed as a series of hard forks. So the first hard fork is the pooled staking hard fork. And then we're going to be doing augmented contracts after that. And then the final hard fork will be the DAO, based on the priorities that everybody we discussed on the last Zoom. So that's kind of a basic overview of where things are now. Progress. So mobile wallet is the #1 priority that we've been working on lately. Now that, as you've checked the roadmap, or if you have, you will see that's marked at 50% complete. We have the backend completely done. Some statistics on that is, and the backend is also not just for a mobile wallet, it can be used for a desktop wallet as well. So we're gonna release that with the first hard fork and some indexing updates and things like that. But what this light daemon does is basically it runs like a full node, so you get the security of a full node, but you only have to have a very small scope. So you're only, think of it as you have a full node is like the global scope. You have everything, every transaction, every sig chain. With the client mode, you're actually just a local scope where you're just only downloading your sig chain. So the end result is, on my personal computer anyway, I can synchronize with the network, with block headers in about 7 to 8 seconds. Some people take 15 to 20 on average, and that's syncing from the first Tritium block. And then the disk footprint is about 150 megabytes of disk space is all that it takes. So that's about the size of your conventional app on a mobile device, and that's with full verification too. So the way that we're doing this is we're actually downloading the block headers from the very first Tritium block. So we have a new Genesis block, I guess you can say. This is part of how we're going to be doing the pruning as we move closer to Amin, is that we have, just lost my place what I was talking about. Sorry, guys. We have the mobile scope. So what it basically is doing is it's using Merkle verification in order to download from the block headers. So the block headers, each one of them is about 100 bytes, something like that. So we're downloading the actual Merkle transactions or the Merkle proofs on it so that you get full blockchain verification, but without, I guess, full blockchain security, but without the disk footprint of a full node. So that's something that's going to be running on all of our mobile wallets, right? We have the snag that we're at right now as far as development is the packaging. So Android allows us to run spawn a child process, but iOS is looking like we're going to have some difficulties there. So most likely we'll be seeing the Android one come out before the iOS one, depending on how we get this integrated together, because we're developing it in React Native. So we need to have this decoupled daemon along with the front end in order to get the same type of structure that we have with the desktop wallet. So in order to do that, we have to run the daemon in the background. So that's the only snag that we're really at as far as a mobile development. All of the engineering headaches as far as client mode and it's basically a sig chain notification and all those things, that's all done, which is cool. And so we've also started implementing some privacy and some locator identifier separation protocol semantics into it. So what happens when you log in as a client node is you log in, you download the block headers, and then you're actually using your crypto object register to sign a message from one of your keys that's in your crypto object register in order to authenticate yourself over the network. So in order for me to subscribe to receive notifications from my specific sig chain, I actually have to prove that I'm logged into that sig chain on that computer. So nobody can just go in client mode and talk to the network and say, hey, I want to spy on, Jeremy's sig chain or something. It doesn't work that way because you actually have to have the sig chain credentials to log into the network to even be able to receive these. So that's a really important step, especially more into the hybrid architecture too, because hybrid mode requires client mode in order to operate. So if you're running a hybrid network, you're going to need to have the state of the main chain, or at least a small state of it. So you're going to be running a client mode node that's going to be running in parallel with your regular network, that's going to be constantly communicating with the main mother network and utilizing the sig chain, right, as the access control. So what the hybrid mode basically does is it allows somebody to own a network, right? Because there's going to be different practical uses, right? The public network like Nexus it can't be owned by anyone. That's what its design is. But there are going to be, you know, certain companies that may say, hey, I want to have this as a localized, you know, blockchain or something like that. So hybrid mode basically allows you to create access control schemes for it. So if you have a hybrid network, you can allocate certain permissions for different nodes that join the network, such as you only have a local scope permission, which would mean that that node can join the hybrid network, but they can only view their own transaction history. They can't see the rest of it. So it's a step towards building more of this privacy into the system. And when you start seeing hybrid networks and things like that, you will be able to control subsets of the data through this hybrid sig chain. So the client mode, kind of how we've been developing is we've been kill one bird with three birds with one stone, basically, right? We're developing client mode to be useful for the mobile wallet. We're also developing it to be useful for a desktop wallet. If you don't stake and you don't want to constantly download the blockchain, then you can do that. That's most likely going to be a default option, so that when you first install the wallet, it's going to be in client mode, which means within 10 seconds, your node will be up and ready to go and you won't have to bootstrap or anything like that. And then if you want to stake, then you'll switch it into a full node and download, you know, the recent database and all of that. So then the third component of it is, like I said, hybrid mode, so that you can use this client mode for different type of hybrid activities. So that is pretty much complete, and it's in merging now. So we're just working on some of the packaging stuff. So the mobile wallet, I would say most of the difficult engineering is done. The sig chain type of notification system was fairly complex to implement. And, you know, putting all these privacy focus in there. And we had to do some really cool like trigger systems with the LLP, because if you're on the API and you submit to say, hey, I want to log in, but you don't have your sig chain, right? You're going to have to do a list sig chain in order to list that sig chain in order to be able to log in, right? So the API actually has to send a trigger to the Tritium LLP and then wait for a node to respond back and then send the data. So we created this really cool triggering system that also extends out the lower level protocol, because this entire Nexus is built on the LLL Tau, right? Which stands for lower level library, Tritium, Amine, Obsidian, right? So the Tau framework built on top of the lower level library. So the lower level protocol is what everything utilizes under the hood. And as you guys know, you've seen the performance without any processing required on the server, just purely passing packets and bytes back and forth, was about 400,000 requests per second. I was able to max out, which is good. That you want the protocol, like for a frame of reference, using the old legacy mode with 100 connections, I mean, the node is practically unusable. I mean, it would have 30-second lags for just like even doing a get balance request, right? So it just was extremely unusable. And the network code was just, it was code that was just built to work. It wasn't something like Satoshi didn't design Bitcoin to be globally used. Like it was an experiment. It was a beta, it was an alpha, and you had a small community doing it. And you know, when it started blowing up, you know, with WikiLeaks, once they started accepting Bitcoin, Satoshi was like, I'm not going to be a part of this anymore. This is getting too big. And, you know, he left. So, you know, a lot of that code wasn't ever finished. And some of the Bitcoin core developers, you know, some of them have kept consistent with that, like Jeff Garza, you know, who's one of our advisors. And, you know, we still communicate regularly. He's an excellent individual, amazing developer. And he has a lot of the insights of some of the original Bitcoin development, which now it's kind of not gone the correct way as far as our perception of it. So, but enough about that. Anyway, so we got client mode, mobile wallet's done. Now I've also been doing a lot of load testing lately. So with this next hard fork they're going to be released with pooled staking, it's going to also be a database re-indexing update, which basically you're going to have to just rebootstrap. Just think of it like that, because I'm changing a lot of the way that the LLD works under the hood. So it's not going to be backwards compatible with the previous database system, but it'll be worth it, right? So previous statistics running on the network now, as you guys remember, it was 5,000 to 45,000 contracts per second. When it was credits, which is the slowest primitive, it would be about 5,000, and then debits would be, you know, 40,000, 45,000. Debits are much, much faster. But the problem is, you know, as you get more and more keys in the system, it slows down, right? That's how every computing system is. The more data you have, the slower it's going to process. And we're all pretty familiar with, you know, why that is. But what I've been developing is what's called constant time. So constant time doesn't necessarily mean that something is superior to, like, let's say a log-n algorithm, but it means that no matter how big the data set is, it will always operate at the same speed. Now, that's a very, very desirable trait to have for our database, especially considering blockchains are a massive global state. I mean, Ethereum's pushing terabytes, you know, for their blockchain size. And I mean, when I tested the LOD up against Google's LevelDB, Google's LevelDB fell apart at about 5 million keys. I mean, at first it was quick. It would write, it was pretty close to the speed of the LOD, a little bit slower. The LOD was doing about 0.33 and Google's LevelDB was doing about 0.55 seconds for 100,000 reads and writes. But then as you start getting more and more keys, the LOD would still continue processing the exact same speed, but LevelDB would just start getting heavier and heavier and slower and slower and slower, right? I mean, to the point where I think 10 million keys, and I was looking at 7 or 8 seconds for, you know, 100,000 keys reading and writing compared to 0.5 seconds. So as you can see, the slowdown becomes pretty significant. And that's how most databases are. They're generally, the way Google's LevelDB works is it's what's called sorted string tables. So it's basically just a bunch of tables that have, key value mappings, key map to a value, and then they're sorted. So they have a little Bloom filter and they check it and yada, yada, yada. So it's a pretty efficient data storage mechanism for write intensive applications. It's much more beneficial for writing, but it's very slow on reading. Like LevelDB, I think I get 50,000 reads per second, records per second. Now, the reason I'm talking so much about LevelDB is that is the database engine that every single cryptocurrency uses, including Bitcoin and Ethereum. Right now, the last I heard, Jeff Garzik told me that it takes 25 seconds to validate an Ethereum block if you don't have a solid state drive, because it's so disk and write intensive. So if you're looking at all the fundamental bottlenecks of the entire blockchain ecosystem, your database is your biggest bottleneck, right? I mean, even synchronizing, I changed the way that I was doing some of the indexing on client mode, and I doubled the speed just with a little bit of database indexing. So that's exactly what I've been doing over the last few weeks. So when everything when the coronavirus went and Bitcoin went and everything, I think a lot of people were probably a little bit concerned about it. And I looked at the situation and was like, hey, what are we gonna do about it? I was like, well, seems like a good time to get, Nexus much faster. Let's see what it could do. Because I hadn't really done as much load testing. I'd done mostly stability testing and bug fixing, everything like that. So I started off and I got it like, 40,000. And then I started finding all these little teeny bottlenecks that started adding up, such as we were using git hash to compare, the state registers or different things like that. And so by removing all of these things, I actually got it to process debits. Now, when I first create a new chain, debits actually process at about 100,000 debits per second. Credits about 25 to 30,000. So we're at about a 5-fold increase from what we were before as far as our processing capacity, but it's way better than just that, right? Because this is one reason I've been so excited about this constant time, because to the best of my knowledge, I have not seen any constant time database applications. There's some, like I think NuDB, NuDB that Ripple created uses a type of hash map, but it's still not fully constant. I tested against NuDB. It was slower than crap. Like it wasn't even a competition with LevelDB. So it's not constant time. I mean, I tested it, get 1 million keys, 10 million keys. It slowed down significantly, but I've been working on this constant time algorithms for the the lower level database for, when did I start this? 2014. It's, in a way, it's kind of like chasing perfection to me, because in order to have something run without having the number of keys be any benefit or any negative effect to it it's your golden algorithm for cryptocurrencies and blockchains and database designs, period. Wow, a database that doesn't get slower when there's more data in it? What? And from my tests, I've been running the node for about 2 days. I'm at 60 million keys. I'm at 25 gigabytes of blockchain size. I've been doing 1,000 transactions or 1,000 contracts per second, just constantly. And it hasn't slowed down. It's still processing 30,000, 32,000 credits per second, and debits are doing 80, 85,000. So I'm getting a little bit of slowdown right now with disk committing, but that's because my SSD is almost full. Because what happens is when you have a very large SSD, you have what's called blocks in your on your hard drive. And so a file is just a link of blocks, but one block doesn't necessarily have to be consecutive to another one. It could be located over here, right? And so when you delete something from the file, it just frees that, and then you use that block again. It just reclaims it. And that's how it works on hard drives. So when your hard drive gets full, what happens is you get a lot of fragmented blocks, right? The SSD is faster in processing. It still gets types of fragmentation. So I have like, I think 20 gigabytes left on this drive. So it's like down to the slim. So I'm just pulling random files all the way, you know, random blocks from random places. So I'm seeing a teeny little bit of slowdown from that, but that's a hardware issue. As far as the database and its algorithm, it's constant time because I was just missing. What we do is we have these hash maps, okay? Hash maps are generally the most well-known constant time algorithm, but you have an issue if you have a collision. So think of a hash map is my key will hash and then map to a bucket, right? And then that's how it's constant time. It's key, map, bucket, done, right? It's the same number of operations for no matter the size of the data set. So what I've actually done, we have what's called linear probing. So when you have a collision, generally linear probing will search like, oh, I'm gonna go to the next adjacent bucket or 2 adjacent buckets over, and finding the most local reference in order to resolve these collisions. And that's how you can get close to constant time from these, you know, hash maps and their design. So the way we resolve collisions is we have a different hash map file for a collision. So we order it by time ordered. So anytime new keys are put at the end, right? And new hash maps are appended to the end of this chain. So you end up just with this long chain of hash maps, right? So if you check the first hash map, if the key doesn't exist in there, you check the next one. If it doesn't exist, you check the next one and then the next one. So as you can see, more keys means more files you have to read, which makes it really slow. And the way that it's optimized right now, when I'm doing a credit to a debit, I'm generally I'm working off of the end because a debit isn't going to be far in these hash maps. It's not going to be deep into the hash maps since it's a newer key. Newer keys are going to be more optimized towards the end so that they're going to be faster access times, right? So that was already giving us type of constant time behavior just by not just the database design, but by how, you know, the debits and the credits and the multi, you know, the dual accounting model works. But what really changed the game is when I implemented Bloom filters. So a Bloom filter is another type of container that's constant time as well. But what's really unique about it is no matter how many keys you have, you don't really run into the collision issue like you do with a hash map, because a Bloom filter is just telling you if something exists or not, which is exactly the issue that I'd had, because before I write a key into the LLD, I have to check if the key's already in a hash map so that I can rewrite that in the data chain, right? And I don't have to constantly be appending, which makes it slower. But when I have Bloom filters for each one of these hash map buckets, right, I can do a constant time lookup to see if the key exists in that hash map without having to touch the disk. That is where we got this really amazing advantage, because now every one of these hash maps has a hash map proper, and then it also contains with it a Bloom filter. So what I do is before I read the disk, before I touch any of these files, I read the Bloom filter. Does this key exist? Now, a Bloom filter has false positivity ratings, which means a Bloom filter could say, yeah, this is in there, and it's not actually in there, right? By the way that it's designed. So you need to balance the, you know, number of hashes that you do, your K hashes, with the total number of buckets you have available in order to get an optimum least amount of false positives possible. But what the good property about a Bloom filter does for you is it tells you absolutely with certainty if something does not exist in the filter, which is exactly what we needed, because when I'm searching through all these things, I'm just looking for a key. I'm just looking for a key to update this record, and I break into linear time. I lose my constant time. I get constant time in the hash map, but then I have linear time with every one of these hash map buckets, right? Which ends up, you know, right now, I think with 60 million keys, I have about 30 hash maps, right? And each one of these hash maps holds 4 million keys, something like that. And so these Bloom filters basically allow me to check memory first and say, does this exist? Oh, it does exist. Okay, then I'll check the hash map file. So that implemented just into the LOD, I mean, it was kind of, how should I say it? When you've been working on something for so long and and then you finally get it, you don't believe it at first. Hey, what? I think we actually just achieved constant time. That's incredible, like constant time database, because that's part of what the lower level library is for. It's designed to be a high performance library that you can use as a toolkit to build high performance, high security web applications, right? Whether they're web, whether they're cryptocurrencies, whether they're anything. So the LOD is useful for many more things than just cryptocurrency. This constant time database, we can implement some higher level stuff on it and make it into a graphing database system as, you know, part of the NoSQL suite and stuff like that, that other people can start to actually utilize in production environments for their web database system, which, if you've ever used MySQL, you'll know once you get to like 100,000 records, like you're going to take like 5 seconds to get your query back, right? Even if you have nice indexing and stuff like it's just really, really, really slow. But in this case, like it doesn't happen. It just got 60 million keys, 25 gigabytes later, same speed. So the downside to this, right? Here's the downside. Here's the downside of this constant time. In order to keep the efficiency of these Bloom filters, I can't access them on the disk, right? They have to be held in memory. But the good side is a Bloom filter is actually really, 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 really small. So it's only about 2 megabytes of memory that you need for every hash map bucket, right? So right now it's 60 million keys and 25 gigabytes of memory. Or 25 gigabytes of disk space. I'm only consuming 180 megabytes of RAM. So it's not going to be as controllable as we have right now because we have this whole caching system in it. So you can literally squeeze it down to like 5 megabytes of memory and it'll still run. It pushes more work onto the disk. But now with these hash maps, we can't just say, oh, well, I'm going to only commit this one to disk, because if the very first hash map Bloom filter is not held in memory, then I'm going to have to hit that disk image, which means I'm going to slow down and I'm going to lose some of my constant time. So we made a little bit of a sacrifice of requiring a little bit more memory. But compared to where we were, where it was like 2 or 3 gigabytes of memory before, I think 200 megabytes is pretty satisfactory, but it will grow about 2 megabytes for every 4 million keys, 2 megabytes of memory for every 4 million keys. So, I mean, when we start getting into like the billions of keys range, what that's like 20 times, 10, 20 times. Yeah. So we'll have about 100 hash map buckets at 20 times, and we'll be about 500 gigabytes. And then we'll take only another 40 megabytes of memory. So when we get to 1 billion keys, yeah, you lose, you consume another 40 megabytes of memory, but you retain constant time. So that was a design decision we made. That's part of the reason that we have to do a database indexing update, because this changes the entire LOD's binary hash map structure. And since a Bloom filter is an exclusion filter, which says this does not exist in this filter for sure, then if something hasn't been written in that filter before, you're going to get false negatives, right? So we have to do this full database reindexing at the same time. But it will be worth it, because what this means for you is that your wallet is going to be much faster no matter how many transactions are going. So if we just get magically popular next year and we're dealing with hundreds of transactions per second, we're not going to run and encounter issues like other blockchains do when their blockchains get big, right? Like if you've ever used any old legacy blockchains that are 4 or 5 years old, you'll know that they are painstakingly slow. They barely function. It takes, running the QT with even 1,000 transactions, like it would just lock up, it wouldn't work. And so we're not going to have that problem, which is good. And we've gotten it solved now, which is great, because we don't need constant time, right? We don't need it, right? We can still function perfectly fine with like log n or something like that, because we're going to do sharding, right, with Amin. But now we don't even have to worry about that, because that's going to make the Amin shards and everything process that much faster as well. So that's been really, really exciting for at least me to kind of be making those breakthroughs. And so now, generally on average, I see 30 to 90,000 contracts per second processing in real time. And the peak capacity I've gotten it to was 12,000 contracts per second, which it processed fine. It starts at about 6,000 or 7,000 transactions per second or contracts per second. You start to see it break down a little bit, but that was on my old tests. So, with this new code and everything, it may be much, much faster. That was before I achieved constant time on the lower level database. So yeah, that is that. Let's see, I got a chat trying to describe, but dang. Sorry, Brian. I get really excited. Poor Jules has been hearing about damn hash map and Bloom filters for like weeks, poor thing. Anyway, so next area of business. I wanted to make a little bit of a discussion on privacy. I think it's a really important trait, and I don't think the community has a clear idea of our stance as a development team on how we're going to approach privacy. In a nutshell, we are focused on privacy, not first. Privacy is something that we're going to be programming in later. Right now, we're working on the foundational elements. We're working on just the core of it, right? Zero knowledge, anonymous cryptography and stuff, that's bells and whistles on top of this foundation, right? Think of it as like a foundation. We're just about done with the foundation 6 years later, which is next. Like the foundation should take you the longest time because that's what everything's built on. And if your foundation isn't built right, like it happens. It's happening to Ethereum right now. That's why they're rebooting their entire chain, because it's just, right? But anyway, there's two ways that you achieve anonymity. One is through confidentiality in your transactions, which means obfuscating the balance. I can't go look up Ryan's account and see how much Nexus he has. That's breaking your, or that's giving you confidentiality. Now there's multiple ways to do that. Homomorphic encryption is one, which is just too slow. It's just not gonna work. So that's something that we're not gonna really be focusing on in that, but I have been investigating bulletproofs, which are range proofs and other things like that that we can utilize to create that type of confidentiality. So we're kind of in research and development phases for the anonymity. One of the reasons that we've put anonymity as a lower priority is because Monero, for instance, the NSA has a botnet that mines Monero, and that's what they use for all their illegal stuff, where Monero is not even anonymous. It's just obfuscation. It's, 5 ring signatures, what one's what, who knows, right? So it's pseudo anonymous still, but it gives them a bat to beat us with, at least for now, right? The transparency aspect gives us enough to defend ourselves against if there are, allegations of Nexus being used for insidious acts or whatever. So I think by the time the TAO is completed, while we're seeing Obsidian, we're probably going to be putting more of the anonymity stuff in the Obsidian update so that we can give things time, we can build ourselves up, but we can also do it slowly and methodically and make sure that we have all of the prerequisites done before that, which is we need to have a scalable foundation. So bulletproofs is one thing that I'm looking at as far as range proofs, zero knowledge proofs, as well as ZK snarks. I'm not super into the ZK snarks just because I think it's really new cryptography. Zero coin, I've seen that since 2013. It was just terrible. I just never touched it. I was like, this is a disaster waiting to happen, and the disaster happened. So we're not going to be doing anything with what the anonymous coins are doing. I think they're experimenting with cryptography that's not fully understood yet. And so we're going to continue to see more problems. So that's another reason why we're waiting, is zero knowledge cryptography isn't new, but the interest in it is. So there's been more zero knowledge research over the last few years than in the last few decades, right? So we're going to be uncovering a lot of things, such as, hey, zero coin didn't work, right? Nobody knew that until now, right? Until people put it in a production environment and it failed, right? Which caused massive inflation attacks. So we want to watch this mature a little bit to make our moves properly, so that when we implement these types of range proofs and breaking linkability, then we'll essentially not have as many of the risks as some of these other people. So that's the confidentiality aspect of the anonymity. Now, the other aspect is linkability. So if I send a transaction to somebody else, being able to link me to that person is linkability, right? To say, oh, okay, well, I saw you deposited this from the bank or whatever, right? That's something that Monero seeks to resolve with their obfuscation method, and UTXO with Bitcoin does do that to a certain extent. Mimblewimble was an attempt at breaking linkability as well. Generally, most of the cryptocurrencies out there that are anonymous are not confidential. They're just breaking linkability, right? Which means I can't trace these coins back to somebody else. And that's important for fungibility too, is you've seen, Charlie Lee and stuff talk about, like, certain inputs are blocked that have been known to be done by negative actors. So the nature of our architecture means that everything is linked, right? So that has become, or that was a bit of a challenge until I had a bit of a realization the other day that we already have actually built something that breaks linkability. And the partial split dividend payments that you do, that is the way that we're going to be doing it. So I'm going to modify that in the future, obviously, to create a type of linkless way to send funds. That's going to include network type routing, right? Because Mimblewimble got broken by a supernode, right? put a node up. He let all the peers connect to him, and then he just monitored what came from what. And he said he linked everything with like 98% certainty, right? So Mimblewimble broken. Why? Because they use the UTXO, where they have kind of like a super block where it's just a bunch of inputs and a bunch of outputs. But the network routing is still really easy to identify. Oh, well, if I'm connected to every node and I see this transaction come from only one node, I know where it originated from, right? So you can link that way. So in order to break linkability properly, we're going to have a type of Tor under the network. So nodes are going to have to route for nodes to route for nodes to route for nodes in order to kind of protect that linkability. But by the nature of it, I could make one debit, right? Or we could have, some of 1,000 different debits that are all collected just like UTXO with their same sets of credits that make it very difficult to discern what links to what. So that's the type of linkability that we're going to be focusing on. Now, like I said, it's all in research and development phases right now. So these are all just ideas. So obviously, if you guys have any interesting articles that you want to pass our way, or, you guys have any suggestions on how we should approach the anonymity, definitely do speak up. It's something that we want to do, but we want to do it in the right timing and do it correctly. And I still stand of the opinion that I think it's still too early to see any of these cryptographic systems be used in production environments. I'd like to see them go another year or two to see how bulletproofs handle, or handled by Monero and things like that. Let them take some of those risks so that we don't have to, which could potentially cause some people to lose money, which we don't want to happen. So now, where else? Pooled staking. Scott would be able to give you a better, he's been kind of spearheading the pooled staking a little bit more than me. I've been just doing architectural development on it, but the architecture is done long time ago. He's just in the implementation phases on it. So we've got some design decisions, like some things like limiting the minimum stake amount and things like that, which Jeremy, we were talking about that yesterday. Chime in if you want to. Obviously, this is supposed to be a group conversation. So, but let's see. Sorry, my brain's just been like off today, man.
Like, well, yeah, if you want, if you're gonna just chime in on the.
You chime in, man. Yeah. I've been talking.
Give you a break. Let your brain breathe for a second.
Thank you.
Well, we were kind of just talking about whether or not, when it comes to pooled staking, there should be a minimum or a minimum amount that should be required for people to join the pool. And just to kind of walk you through the thought process, at first, the idea is, well, we want people to have to kind of be invested in securing the network, and we want them to take that idea, and also the fact of if you have like a minimum amount, let's say 100 or 500, whatever it is, then on one hand, it's almost like locking funds without locking funds, because people are going to want to stake their coins, their tokens. But then we also, thinking through it, we also want to go with the ethos of what Nexus is and focus on the community aspect of everybody is a part of this. We want everybody to be feel like they're a part of the community, feel like they can contribute to the community. And one thought that I, as an American, didn't even consider was, if you think about like globally, what 100 Nexus costs, for somebody in the US where it's 15 cents per Nexus, that might not seem like much, but when you go to other countries, that's actually a considerable amount of money. So if we're thinking on a global scale, having no minimum, well, the minimum would be like one, right? Like one Nexus, because we don't want to deal with fractional numbers, but having one as the minimum to join the pool, it's the most welcoming way to get everybody to contribute to the network, to get them to want to be invested. It gives everybody access. And the more I thought about it was, if people start with one, they're more likely going to want to get more. As soon as they get that one and they see that it's working, they're going to want to get two, and then three, and then four. So in a way, it's actually a better, marketability wise, I feel like it's better for reaching out to a larger audience. And so that was just like the conversation we had going yesterday. And, as long as I believe it was Simon was saying that it didn't affect security. So the number one concern is obviously network security. So as long as the limitation on if somebody pools one Nexus, is that going to impact security? No. Well then, yeah, why not let somebody pool one Nexus?
Yeah, exactly. And part of the way that it works too, so that you guys know the algorithm is the pooled staking protocol is actually going to make the proof of stake system more secure, right? We're going to still allow solo staking, but based on the incentives, people are probably not going to solo stake anymore. So the way that we gain this extra security is when this person, let's just use Jeremy's example, that he had one Nexus and he's staking with that one Nexus. He is going to be basically submitting out to the network saying, hey, I want somebody to stake for me. And then they're going to take off a small fee so that the person that's actually doing the staking will earn a block finder's reward, right? But in order to do that too, this person has to submit proof for the transaction history that they are verifying, right? Think of it kind of like a Merkle root. It's not quite a Merkle root, but it's similar. It's just a proof that you can know, okay, this person's one Nexus that they're staking with, in order to be a block finder, have to stake the exact same transaction history as them. So what you start creating is when you get 100, 200 people in a pool creating a block together. Now, instead of it just being one person is the one that won, right, and was able to set the transaction history, now it takes 100 people to agree on the same set of transactions in order for it to actually go through and be considered a valid block. So I think that's really important. Does that you, Scott, Simon? Or is that another Scott? I was going to say if Scott's on here, he should do some more of his talking. Is that you, Scott?
Yeah, it's me. I'm muted.
Yeah. Take over the pooled staking. That's your.
You're doing fine.
Yeah. I mean, Scott's doing a lot of the implementation. We've been working on the algorithms. Scott's kind of the main staking guy. He's just become Mr. Staking expert for a while. It's really cool.
There's a couple things that we can add. We can think of it isn't a pool in the sense like a mining pool where everybody combines to work on one block. It's like if there's 100 nodes, it's actually like 100 different pools. Each node has its own version of the pool. And while, like Colin just said, all of the CoinStake transactions have to agree on the transaction history that's in the block. Each different node that's staking it may be including a different subset of those coin stakes within the block that it's staking, depending what it sees of the pool. So it's kind of cool how it'll all work is in that it can be very local, like a little group within the network that tends to be communicating a lot because they happen to be close together, that they'll be working together to stake in the pool, whereas somebody on the other side of the world may be putting together blocks that have different coin stakes in them, but they're working on the same block. So it's not like it's one big pool. It's almost like your own view of the pool is its own separate thing from everybody else's view of the pool. And that can result on, different sets of coin stakes included in the block. Because when we say it's a stake pool, it's not like all the coin stakes are combined all together in one block and everybody stakes that block. And then everybody's stake goes on cooldown until their interval is up and they can start staking again. We want to be able to support, multiple stake blocks being found within the pool, while like your local SIG chain may be on cooldown because it just found a stake block 10 blocks ago or was included in one, but there's another part of the pool that's still working because they weren't, and so it won't be all one big pool. I think that's
they're self-organizing pools basically.
Yeah,
I mean, it comes down to what people just choose, who they choose to work with and who they choose to stake with. So there's no designated leader. There's no one person that you have to subscribe to their pool. It's just a general, everybody can be a block finder and everybody can search, right? Or everybody can request for somebody to stake for them. And based on what people decide to include, and they have the absolute choice. I want to include this person's one Nexus input. And maybe they don't want. Maybe they're like, hey, one Nexus, that's not very much. I'm not going to do it. But somebody else may do that, later down the road. So this gives people as much opportunity as possible to kind of self-organize into these pools rather than it being a top-down. It's like a bottom-up structure.
Right. And, another point to point out is it might combine, say, 20 coin stakes into one block within your local node and start hashing that block. And what it will do is it will hash the full balance of all of the coin stakes that you included with your local level of trust for your sig chain. So effectively, it allows you to stake as if you had that balance yourself today, but everybody is looking for this block at the same time.
Yep. And if you guys heard what Scott said, he said about, oh, sorry, that not everybody in the, my gosh, brain fart. This is something important. Oh my gosh. I think I've been working too much lately. So Scott said something important though, I remember, about the block finder in the pool and the discernment of being able to stake for somebody's balance. That's what it was. And that you stake at your own trust level, right? So you can't use somebody else's trust. So what's going to end up naturally happening is the people that just end up with, that have bigger trust keys, they're going to end up being the block finders, right? So it's another way for, because they're going to have the higher probability of finding these blocks. So what it's going to do is it's going to essentially give people that have full trust, you know, another way to monetize, because they'll be able to earn some percentage of pool staking fees if they stake for people. But this way it allows people to build up trust individually, right? But pool together their stake or the amount of Nexus they have in order to fulfill that. But with every Nexus that you include, it has to be the exact same proof that you yourself included in your coin stake. So that way you can't just stake somebody's Nexus as your own and try to Finney attack the network or 51% attack or anything that you would do like that. So that's how we get this higher degree of security, but then we increase the availability, because we had this issue where it's like, well, if we make Nexus 2 available on the staking, then the security is going to go down, right? And then people will be able to attack it. So this was a nice balance that we found between, where we can improve the availability for anybody to be able to stake, while at the same time improving the network security. So it's come together pretty. What do you expect, Scott, as far as when we're going to be moving into testing phases on the implementation?
My goal is by the end of the month.
Okay.
We'll see.
So
we'll see how much I can get my daughter to leave me alone.
Oh yeah, we're all like we're all kidding it up, man. Like
it's
all of
been
us,
tough
all
with
of
her
us
home from school.
Oh yeah, I got 2 at home, a 6-year-old and a 7-year-old, man. This is like, it's rough. So yeah, we're shooting. So I'm guesstimating probably by mid to late June, we're going to be seeing the hard fork. As far as our testing, everything is pretty much done that I want to include on it. We just need to get the final implementation of the group staking and stuff like that, and testing obviously and all that. So I'd expect Tritium++ to be within the next couple months, or the very first aspect of it. And then augmented contracts, like I said, is next. So let me explain augmented contracts a little bit for you guys.
Before we move on, let me add one more thing. And,
Yeah.
It might be a little soon, because I'm still playing with how these settings are all going to work. But someone had posted a while back when we first introduced the idea that the pools would be self-organizing. Like, what if I'm like in an eddy in the pool, right? So I'm building stake block, it has 20 coin stakes in it, and all of them are people staking with 1 Nexus or 100 Nexus, and I'm stuck here and I can't ever find a block. And we're working to address that, and part of that also has to do with how many people can we support in the pool, because we don't know if there's going to be 100 people or 10,000 people, right? So we have to support different levels, and so I've mentioned the number 20 because that's the base that I'm working with right now. Is when you first come off cooldown, and your interval's up, the number of blocks that between right now it's 240. We're going to be lowering that to the number that we're planning on is 60. So after 60 blocks, you could begin staking again since you found your last one. And then when you do that, it would start building blocks that include up to 20 other coin stakes in them, right? And then you have your trust would have 72 hours before it would start to decay. So if you don't find a block right away, as you proceed through that 72 hours, it will gradually increment the size of the number of other coin stakes that it will include in the block. So your local pool will be staking more and more other coin stakes in the blocks that it's attempting to hatch. If you're stuck in an eddy, you're gradually going to expand your view of the other people on the pool and include more of them in the block, which will increase your balance in the block and give you a better opportunity define one before it would ever reach that 72-hour limit. That's what I'm working on with right now. It's what we talked about yesterday, was how are we going to do these settings, how are we going to adjust them. I don't have the exact numbers yet. I'm throwing out 20. That's what we're working with right now.
Excellent. Thanks, Scott. So for everybody, so I'm going to jump into augmented contracts. So for all of you that know, one of our big, I guess, aspects of Nexus that makes it desirable to build on is that it's API driven, right? So that you just as a web developer can just invoke an API command and boom, you have your dApp. So we made it extremely easy for people. That's why we're developing things with React Native and things like that. But augmented contracts take this to another level, right? Augmented means improved, increased, right? So it's basically taking the smart contract functionality that we have right now, and it's giving developers a lower level aspect to the API. So what it's going to include is domain specific languages for object modeling. And what it's also going to include is functions and methods and operator overloading. So basically, function is something that changes, it just performs some specific action. You invoke a function, it performs a specific action. A method is a function inside a class or an object that is essentially operating on that internal data of the class, right? So then operator overloading is in C++ anyway. I could take an object and I can overload plus, right? And say, well, when I add this object to this object, I want this to happen, right? That's an operator overload. So what we're doing, we have primitive operations, right? Which is debit, credit, transfer, claim, write, append, legacy, like a few, I think there's like 15 opcodes, right? So when you do an operator overload, what you're actually going to be able to do is you're going to be able to program into the network your own specific rules for validating a specific primitive. So if I have an account, I can overload the account with a debit operator overload and say, only, 10 Nexus can be pulled out at a time. And I can say, if the amount of this is greater than 10, then return false. So what's going to happen is you can put limitations and program your own specific validation code into the actual objects themselves, right? So this is going to give us, based on the architecture, we're going to be more Turing complete than Ethereum as far as we're going to support floating points, right? Nobody supports floating points in blockchains because they're not consensus safe. Floating points have different hardware interpretations. IEEE 754 is the floating point standard, but it's not always honored. And, like ARM processors, for one, only do, 32-bit floating point instead of 64-bit floating point precision, single point precision instead of double point. So I actually managed to figure out how to create software virtualized floating point. So I didn't create it necessarily. I found a library that did it. It was called Berkeley Soft Float, right? Coding IEEE 754 stuff, like, dude, I was beating my head over it for a while. So I was reluctant enough to come across some of that. So I had to modify sine, cosine, tangent, log, and E in order to get this. This is before Tritium. I had to get our soft float E, like exponentiation, to equal the exact same hardware precision, right? In order to essentially have a consistent precision across. Because when you're doing any sort of, floating points with, let's say, Bitcoin, because Bitcoin has 8 digits, right? You basically are dividing by that number, 10 million or 100 million, right? You're just having a bigger number and you divide by 100 million, and that's kind of what's setting the decimal place. So they're doing all integer arithmetic. So what this does, this soft float library, is it allows us to do integer arithmetic with floating points. So we get all of the functionality of floating points with integers, which means it's consensus safe. So inside the augmented contracts virtual machine, we're going to support float and double in the smart contracts. Now, the other aspect of it is it's a type of call and response system, right? So with Ethereum, it's just like, hey, I execute this. It goes goes into the little turner, and then, it goes on a block and yada, yada. But with us, it's going to be much different because it's a call and response. So when I want to execute a method, let's say in Scott's SIGchain, I'm going to do a primitive called invoke, and I'm going to set invoke out there. And then Scott, depending on the privacy of his method, if it's a private method, that means I can't call it. So my invoke's going to be rejected. If it's a protected method, that means Scott has to execute it. Scott has to respond to me, and he doesn't have to respond to me if he doesn't. So that'll create interesting types of smart contracts where you need to have these call and response systems where it's like, I'll invoke you, and then they invoke it. And then what happens with invoke 2 is you have what's called a callback. Okay, so it's asynchronous. So Ethereum's been trying to create asynchronous smart contract behavior, but I'm not sure exactly to what level they are with us. This is asynchronous smart contract behavior, and it gives us extremely high scaling properties as well, because we're only operating on the object. Since the methods are going to exist inside an object register, I have all of the data. I'm only manipulating the data within that object, so I don't require much outside of the scope. So even with augmented contracts, we're still going to be saying the same contract processing. I mean, even these load tests I've been doing, every one of those transactions had a conditional state on it, which is using the conditional virtual machine, which was programmed, right? So it's fast. It's really fast. And augmented contracts are basically going to give you as a developer the ability to program deeper into Nexus. So protected methods allow you to say, okay, well, if I have this account and, you know, I want to assess things before they're executed, I want to see what my state will be before I execute it. I'll see that and I'll say, oh, well, Scott wants me to execute something that I definitely like isn't in my favor, so I'm not going to execute it. If it's a protected method, I have that freedom. But if it's a public method, it's different. That means it's forced to execute. So you do public methods with like gambling systems or lottery systems or things like that, where somebody needs to be able to call it. But then you also do public methods with like, if I want to put a lien on somebody's property because they owe me money or something, right? I would be able to execute one of their public methods to put this lien out, right? And then you can create these types of contracts that allow you to have them self-execute. Even like watching the movie The Big Short, where he had these swap contracts and everything. I was just like, oh, we could code that, right? But the missing piece was this call and response system and the callbacks, right? So if I invoke Scott's method, I'm going to invoke it, and then I'm going to send a callback with him saying, I want you to call this method back to me once you're completed. So it's going to be, I'm going to go out, I'll wait for Scott to respond. Scott responds by executing the method, right? He'll run up, execute, and then he's going to do an invoke on the method that I asked him to call back, which is going to go back to me now executing, and then I can continue executing what I needed. If I needed something from Scott, it basically waits for Scott to respond, it comes back, and then I continue my execution, right? So these smart contracts will be executed kind of in steps, but it's going to be giving us pretty much more power than Ethereum without having to be necessarily Turing complete. We're not going to support like infinite loops and things like that, because that's just nonsensical for a blockchain. A blockchain is a verification system, right? It's not a computer, right? The whole world computer model is a really bad idea. We want to be able to verify data. We want to have verified computation, right? Which if I'm doing a debit and I'm, debiting 5 Nexus from my account, that's verified computation, because the operations layer is verifying everybody is calculating the same number. And that's what these augmented contracts are going to give us. But then with this operator overloading, what we create is we create another aspect where we can create these types of protected assets, right? So I could issue a token that only I have the power to actually debit, because I just do in the operator overload that only I can debit it, or I can only credit it. And so what's going to happen is somebody is going to basically be able to execute that. And you get this, how should I say, incredible use with it, because if I want to do like a split dividend system, right? Or I want to donate some money to this nonprofit or this charity or whatever, but I want to make sure that I can revoke my donation stream to them at any point that I want. I can create 1,000 tokens, and then I can have my donation streams come into the asset that's tokenized by those tokens. And then having a protected token, I transfer those tokens to each of the people that I want to receive donations. And then at a point in the future, I can revoke those tokens back because they represent my internal revenue, right? My donation stream. So you can do the same thing with companies, right? You have the income coming into the company, you split it into departments, and you can utilize these tokens and these protected assets to do that. So that's going to be something I think that's really important for seeing a lot more use, especially with equity agreements. And that's something that we've been focusing on too for use cases is, company startup kits, right? Like get your operating agreement put on the blockchain, your equity agreements. You can have, voting systems done on the blockchain. I mean, there's a lot of potential that we have with these things. So augmented contracts are, to me, they're a really, really, really important facet of Nexus. And I think it's going to bring in a whole other set of developers, especially as they get more and more frustrated with Ethereum. I think the days of Ethereum are numbered, and they know it. I mean, they haven't grown for God knows how long. And I mean, the price went down the other day, and like all exchanges shut down every single ERC20 token because Ethereum just was not working. It happens, and Ethereum 2.0 may help, right? But I just think that their foundational architecture is just flawed, and I think their practices of implementation are slightly flawed too. And I think they're relying on too many third-party things, which is just, it's in order to get these blockchains to the level that the world needs them to be, you have to go through every nook and cranny of every aspect of it, because you leave these rocks unturned, like they come back to bite you in the future. And I've learned that from my personal experience. It's one reason why we're so diligent in, what we develop and how we develop and our quality assurance processes and everything like that. So augmented contracts is going to be a really important cornerstone. So that's going to be a hard fork after this pool staking hard fork, right? And then we'll probably drop hybrid mode in along in the same time. Hybrid mode actually might come out on this first hard fork, so that anybody that's running a private network will be able to basically utilize a hybrid mode, which is also going to incur fees on them, so that any company that wants to run their own private blockchain is going to be generating economic incentive for the public network. They're going to be paying us back in a way, right? Because there's a lot of people that are just using free open source software. So we need to make sure that that which we've developed that may not directly benefit the community can somehow indirectly benefit the community. So creating these fee models in with hybrid mode is going to be a way that we can start to capture some of that economic activity for enterprises or any companies that want to start utilizing Nexus. Now, the final one is the DAO, right? So the DAO is, technically it's already here. We've been doing a lot more DAO activity. I've seen the community really getting in the DAO mindset, which is really awesome. Props to all of you guys, T, Jeremy, Scott, Ryan. You guys have just been being amazing. It's just, I'm really grateful for the community and all of you guys. You guys have just really pulled things together and taken things into your own hands. And that's what's going to make Nexus successful. So the DAO is our final Tritium++ feature, which is going to allow us basically to be voting and cryptographically enforcing the fund allocation. So right now is actually a really good time for all this community activity to be happening, because the DAO is coming. So, you guys, you may be, volunteering right now, but you could be running an embassy in a year. You never know, right? So that's part of how it should be. It should be that, people can rise up, based on their merit to become, something more than just a simple bystander that want to actually take active part in ownership in, the development of the protocol and the development of the network. And, eventually to get ambassador contracts and run embassies. Or, one of the things that I see these contracts being used for is, think about how many impoverished places there are, right? Think of Venezuela. All these places are just completely, their economies are completely screwed, right? So, going in and being able to provide jobs for people, being able to help create permaculture systems where they can cultivate food so they can eat, right? Many other things. There's a lot of really powerful things that we can do on a humanitarian level for people. And I think that's something that's really high on my priority list, because the world needs some help. And, I think we're getting more and more in that type of position where I think we will be able to provide that, especially as we're seeing this technology materialize how it is. And last thing I want to say too, I know I've seen a lot of people say that tech doesn't matter, and that's a narrative that's been going around, especially developed by the people that don't have good tech and good marketing. But fundamentally, I'm going to use the analogy of AC versus DC, right? Nikola Tesla versus Thomas Edison, one of the best examples of this. Thomas Edison electrocuted elephants with AC. His marketing, he was supported by JP Morgan. He pushed with every ounce he had to get DC everywhere. But guess what? It's not everywhere. You know why? Because it didn't work. You go, and when you're pumping high current through a wire without using the voltage potential and transforming it, you're going to get massive resistance. So every few miles, you're going to have to just pump that power back up. So you're just losing power, and it's just gone, right? It's just evaporating. So it just was not possible. And it reminds me a lot of Bitcoin, DC in the early days. It was around, people kind of used it, but if too many people needed it, there just was too much infrastructural need, and it just would not supply the requirements of the general population. Bitcoin, Ethereum, they remind me of the same thing. Bitcoin falls apart at 2 transactions per second. Ethereum falls apart at 10, right? And the technology, the point where technology matters is in building the foundational usefulness, right? If you can't use the technology, if it's too complicated, if you lose your wallet.dats, if you have to sync this giant blockchain, if it takes you 90 days to sync the Ethereum blockchain, like it's just not gonna work. No matter how good your marketing is, no matter if JP Morgan Chase endorses you or Bill Gates is, making all this software for you, it doesn't matter. Because if your network falls apart how should I say, if it falls apart before you're able to design it great, it's not going to work. And AC ended up winning because it was the superior technology. It wasn't marketed as well. Edison, he electrocuted elephants, like trying to scare people and show people how scary and bad AC was because he was so threatened by Nikola Tesla. But those types of things, they only last for such a short period of time. They don't build any long-lasting, meaningful impact on the world, right? It's just some guy being an asshole, pardon my language. And it only goes so far. Look, Tesla, Edison rewrote the history books to try to wipe Tesla out of it. All of the victors and whatever, and all of his technology just wiped out completely of the history books. But yet we still know because Tesla's impact was meaningful. Tesla's impact did something. And that is kind of how I see us. We're building AC, we're building the transistor. I mean, Bitcoin's the vacuum tube, right? It is good. Like it showed us that we can build computers, we can do logic gates, all these things, but it's a transistor that made it cheap enough and small enough to fit it in everybody's pocket. And that's exactly what we're creating. So it does not mean that we're not doing marketing because T and his whole crew are just slaying it with marketing. I mean, they got us, we're top mentions on Twitter almost every day, trending. Like you guys have done amazing. And I can't thank you enough. So it doesn't mean that we're not going to do marketing, but I just wanted to put that in your guys' ear just in case there was a perspective that was maybe not fully correct. Because I've seen this thrown around a lot, and I've seen a lot of people say nobody cares about tech. And I agree, people don't care about tech. People care about being able to use something that they're told works. And there's nothing more frustrating to people than trying to use tech that doesn't work. And I just sent Bitcoin the other day. Took me 5 hours and $5 to send the Bitcoin. And Bitcoin's like not even making a bull run, man. I mean, I can only imagine what's going to happen. The fees were $200 on the last run. Like God only knows how much they're going to be this time, right? So I think that's just going to create more and more openings. I think the trying to limit Bitcoin with the block size to push everybody onto the Lightning Network, it's just not an effective strategy. It's not going to work. It's people want things that work and they want technology that works. And the promise of cryptocurrency, I personally believe, has not been met yet. There's too many trilemmas and there's too many God complex developers and like all this. It's just, it hasn't been met yet, but we're focusing on, hopefully getting there. And we're 6 years in now, and we've probably got another 4 years left before the TAO's done. I'm shooting my internal, is by 2024. By the time the emission is complete for Nexus, that's when it is. And that it's perfect for Scott because he always says, good software always takes 10 years to build. And that would be exactly 10 years. So I'm presuming most of the heavy lifting and development in 3DC and anonymity and all that stuff will be done by 2024. So we're getting close. We're getting really close. And seeing this order one database, that's been something that's been keeping me up for a couple of years, if you guys hadn't noticed. So getting an order one, I'm very satisfied. I guess that pretty much summarizes everything from my side. Does anybody have any questions? Anybody want to start some discussions? Or are we pretty good to wrap up? No questions? All right.
Well, if nobody else is going to say anything, I just want to say I love the energy, man. Like it brings positive vibes, man. And when you're excited about these breakthroughs, it tells everybody else, it lets us know how valuable and important they are.
Hell yeah, man. I mean, that's what we're here to do.
Work, man.
I appreciate you guys too, man. Like we're all here. Like the world needs some light. Like let's spread it. Let's spread some positive. Let's spread some love, man. Like let's do it. You guys are awesome.
Colin, yeah, I second that point. Is U2F or two-factor in scope or being worked on still?
What's that?
Is U2F or two-factor?
Yeah. So U2F is a separate type of signature. So in order to do multi-factor, that's a good question, actually. Thank you. I'm going to create, so I'm going to, again, kill two birds with one stone on this algorithm. I'm going to create a multi-sig chain. Okay, so your next hash will just be, here, Ryan, I'm going to mute you real quick. So it's going to be a multi-sig type of sig chain. So, you have a next hash, and that next hash is just the hash of the public key, right? And you have to generate a valid signature with that public key in order for it to be considered a valid transaction, or you technically authenticate it. With this multi-sig, what we're going to do is we're going to allow you to submit multiple public keys. So I'm going to create a crypto type virtual machine script thing where you can just code crypto stuff into the next hash. So it's going to be kind of a little mini assembly programming language, which will allow you to include multiple signatures and multiple key types. So isolating UTF, you should be able to just do a single generating transaction with your regular public key, which is your authenticated public key. And then you append or concatenate your UTF public key, and then those two become the next hash. And then when you're verifying the transaction, you verify multiple signatures, and each signature obviously correlated to each public key. So that, after a lot of deliberating as far as designing a decentralized two-factor authentication system, you were right all along, Brian. That was the best way to go. Maybe not necessarily UTF, because I know that had benefits for the hardware being integrated with existing crypto wallets, but the second signature is the only way that we can really effectively do it securely without running into any issues. I kind of had an algorithm with like this deterministic mathematical equation where you wouldn't have to have any device-to-device communication. It's not, it's just, it wouldn't be secure enough. So we need to do this multiple signatures required. So when you do a two-factor, your desktop wallet will create one signature, and then your mobile wallet or whatever else will create the other signature. So the transaction is going to be broadcast to the network as a partial, right? So everybody's going to receive it into their memory pool in a special mempool saying incomplete transaction. And then any node coming on will then check the mempool and say, oh, I have an incomplete transaction, which is my currently logged in sig chain. I need to generate a 2FA code, and boom. So you're going to have device communication or network communication between your 2FA device and your desktop wallet, but we will get the full security of that. And like I said, two birds with one stone. We'll get multi-sig sig chains, which will allow multiple people to have multiple logins, right? In order to, access the funds and require everybody to log in and generate the transaction and generate a signature. But then we'll also get benefits of UTF and multi-factor, and it doesn't have to just be a UTF. We can use and support UTF as one of the specific key types, and then obviously different types of 2FA. Like if we build a 2FA on our app, that can just be another simple signing if you want to use Falcon or something, because UTF isn't using quantum resistant cryptography. But we're going to set it up so that we have as many availabilities as possible. And then one last note, I'm also doing some research into biometric. I have a friend that's been working on biometrics for a long time. So that's another type of research project they're working on as far as biometric usernames, which could be face recognition scans or things like that. So it won't be anything that authenticates you, but it'll just be part of the entropy that you use in your sig chain. So in order to hack your account, you would need the face scan along with the password and the PIN. So it just increases our security. And then obviously the two-factor authentication method on top of that. So layers and layers of redundancy. We have enough layers to be secure right now, but we're definitely adding more.
Hey, Colin, if you can hear me, just wanted to ask, how are things progressing with vector space systems and the CubeSats going up? And what do you think about Elon Musk Starlink, where he's deploying satellites for the internet?
Yeah. So I can't go into too much as far as the satellites. I can say this, I have recently picked up, I made a lot of breakthroughs on the satellite technology. One of our biggest issues was frequency licensing. And I'm pretty sure I found some ways through that using a few different methods. And then combining that with phased array antennas, that gives us high directional gain for very small sizes. So I'm looking into the about 5 gigahertz band, ISM band, to see about working with that. And I'm also starting development on an operating system that's going to be running on these IoT devices and on desktop computers. It's not going to be consumer oriented first. It's just going to be for devices. So think about it as a blockchain authenticated operating system. So right now, your computer is just like a big thing of jelly, right? Like I, as a virus, can just inject whatever the hell I want into there, and the processor is just going to process it because it doesn't know any better. But what we're going to be doing is we're going to be check signing and doing file integrity for each one of these files in the operating system so that you can't remotely inject anything. So it's going to be an extremely hack resistant consumer operating system, but it's also going to do to your computer what your SIG chain does to your wallet.dat. So your SIG chain will become your computer combined with the LOD file system. Your computer won't live on your computer anymore. It'll live on Nexus, and then your SIG chain will allow you access it. So your file system will be a combination of local file and remote files, right? So that's the OS, which is going to be running on these satellites. Elon's Starlink, I mean, it's just something that he's using to make money for funding his mission to Mars. So, I mean, it's just another space-based ISP. From his recent comments about fascism and fascist governments, I'm more hopeful that he is doing the right thing. But as far as Starlink, it has nothing even remotely related to what we're doing. It's just providing an ISP access to other people. What we're doing is we're creating a gamified incentivized satellite constellation that will build itself, right? The blockchain builds itself because there's incentive mechanisms built into it to reward miners for building it, right? So the same concept is what we're going to be doing with the satellite constellation. So in a way, there really isn't much competition because we're not just trying to single-handedly do it. We're putting together a crew of people that are doing it. And I've already got some people that I'm starting with the white paper for this OS and like getting the right people. And we're keeping it pretty low key right now because we don't want to talk too much about satellites until we have proven results from them. And unfortunately, over the last couple of years in the bear market, we just didn't have the funds available, and Vector's demise obviously set us back. But we have actually since not only recovered, now Vector obviously is done, but we're working on some other things that are making it much, much more viable than it was before, especially with the way that we're designing it. And it will become a way for more people to monetize, right? So you will invest in putting up a satellite because you can earn money from that satellite, right? And it's going to be gamified in with the entire crypto and then running Nexus OS as well. So that's probably, we're not going to be seeing probably any results for that for a couple of years, I'd say. So I wouldn't think that you're going to see anything soon, but we're definitely in the design development phases. We have kind of a working group I've been putting together with the right people. So if you're interested and you want to be a part of it, I mean, we're pretty much in the how should I say, the early phases of getting our architecture correct. And then from that, we draft that into a white paper and then continue developing some more of the hardware. I actually have a couple meshes over there because I've been playing around with, 2.5 gigahertz Yagis and stuff and 40 megahertz. I've been actually playing around in Zenit ground waves and other cool stuff. So we're making progress on it. It's a little bit slower, but we're focusing on mesh networks first, which is what I've been playing around with DDWRT firmware, modifying routers and stuff. And then the only other snag that we have is developing the routing system because it's kind of like a reverse binding. You have to bind to like a geographic location or bind to a cell rather than IP addresses. So obviously, got a few people working on that, but yeah, it's definitely moving. Personally, I think we've made more progress on it this year than we did the prior years before, because a lot of what before we were relying on Vector and Galactic Sky. But now we've kind of taken things in our own hands, and we've just taken the situations at hand to say, okay, well, we've learned from this, so we're going to do it right this time. So that's it.
Thanks for a very detailed reply. I wasn't expecting it to be this detailed, but I really appreciate all your time and effort. Thank you so much.
You know what they say about expectations, man. Better not to have them, because then you're always surprised. All right, guys. Well, I got like 3% left, so I can like answer one question, I think. But I'm gonna probably die. My laptop's gonna die in a minute. Anybody have anything you want to ask before we close?
How different or similar is a satellite design to Space Chain, and are you still working with them?
Oh yeah, we're working with Space Chain. We're actually they're partners, so we're basically their design is totally different from what we are. They're just running Raspberry Pis on a 3U and using UHF VHF. But what I've discovered over the last few months actually is going to be something really beneficial to them. So I've already been discussing things with them. So yeah, we're still continuing our development. We still have a good relationship with Jeff Garzik and all of that. So That's moving along. They're going to be part of this because we're designing it to be a decentralized collection of satellites that are all independently operated and owned, right? So we're putting together that initial crew to get, I think about 60 up is what we need to get full ground coverage to kick it off. So when we get architecturally to that point and the markets get a little bit better, we're going to probably be seeing some more talking about that. But yeah, as is right now, yes, we're still working with Space Chain. Our design is slightly different. They're just running full orbital nodes. We've isolated what is the value proposition of a satellite, and running a node on a satellite doesn't really have any value. The value that we see is having physical isolation for the storage of data, right? So if I have sensitive data that I want to be stored in physical isolation from the ground, then I'm going to pay a premium fee for the satellite constellation. So these people, it'll create this free market dynamic in the constellation, because the more demand there is for data storage on this cloud that's in low Earth orbit, then the higher the price is going to be. And when the price goes up, then there's going to be more incentive for people to deploy more satellites, right? So we're hitting this from multiple angles as far as like satellite ready kits, like, Nexus OS. Like, you should be able to just build your CubeSat, load Nexus OS on it, launch it, and then it'll find the constellation and join it. And then we'll have a type of reputation system as well that does part of the selection algorithms. But this file system that's going to exist on the satellites is an extension of the LOD file system, like I was telling you. So you'll see the LOD file system exists beforehand, which is basically selling some hard drive space in order to monetize, right? So that gives people opportunity that may not have jobs or whatever to run their computer and earn money just from selling some of their disk space. So it's that same concept, but just instead of it being on a physical device on the ground, it's going to be in low Earth orbit. That's the first value proposition. The second one is routing, obviously transcontinental routing. But I've been doing a lot of research, and I'm going to start reaching out to some more people that have been working what's called xenic ground waves. A xenic ground wave is actually a wave that hugs the ground. It moves over the ground like this. Nikola Tesla actually discovered it. Wardenclyffe Tower, if you're familiar with it, was using xenic ground waves. That's why it's 20 meters tall, because he was using 12.5 megahertz, which 20 meters is half of the wavelength of 12.5 megahertz. So he actually was able to transmit through the ground, because a wire, it will, when you're sending a signal through a wire, you're sending a wave. You're not passing electrons, you're sending a wave through the electrons. And the wire acts as a waveguide. It directs the wave, but normally when you send out just an electromagnetic wave, it's just going to go out. It's going to dissipate at the inverse square. A xenic ground wave actually makes the ground turn into a waveguide. So that's how Tesla lit up light bulbs on the ground, right? And all that type of stuff. So that's another thing that we're looking at too, for like mesh networking type of capabilities to also help us have bandwidth. And so the frequency I'm looking at too, just the last little detail, at 5.8 gigahertz, I think at quadrature amplitude modulation 1024, they're able to get 5 gigabits per second per channel. So the frequency that we're looking at seems like it definitely is high enough of a bandwidth, but it's what's called an ISM, which stands for Industrial Scientific Medical, which is a free unlicensed frequency that you have to obey their broadcasting limits, I guess you can say. But I found with the proper phase array antennas and 1 watt, we can actually make it 1,000 kilometers with a 5.8 gigahertz ISM frequency. So that's the same, for those that don't know, the same frequency that your Wi-Fi uses. And that's how Wi-Fi is able to be out for free, and they don't have to get frequency licensing for it. And even if we did like UHF, VHF, like Space Chain's doing, they can only broadcast over the US. They can't broadcast over China, even using UHF, VHF, because it's an amateur radio signal, right? ISMs, 5.8 gigahertz, is an ISM in every single country in the entire world, right? So that's a big breakthrough. But I think I got 1% left, so I think I need to go, or I'm going to be forced to. Everybody, thank you for a wonderful. This is a great Zoom. You guys really interactive. Thank you guys for chiming in. I think you want to do bi-weekly Zooms. Is that good for you guys, or monthly?
Either or.
Either or. All right. Well, let's see how we feel in a couple of weeks. Let's just play it by ear, and yeah.
Let's do it monthly,
right.
so you're going to get more work done.
Monthly is probably good.
Monthly is good for me, man. I'm happy with monthly. Okay, monthly. Cool. All right, guys. Well, we shall see you next month. And thank you, Brian. Thank you, Jeremy. Thank you, T. Thank you, Aries. Thank you, Kendall. Thank you, everyone. That's been amazing. You guys are awesome. It's great working with you guys. So peace and love.
Thanks a lot, Colin. Take care, everybody.
Bye.